Algebra 2. We are now starting Chapter 8. We're going to be doing Part 1 of the first two sections of the chapter, and today we are going to be graphing exponential growth and decay functions. So at the top we have a definition. It says that an exponential function has the variable as an exponent. So where we're going to see the variable x, it's going to appear as the exponent, which is what we see happening right here. The x is the exponent. We're going to have a base that's a number. It could be a 2, it could be 10, it could be 1/3, but our variable is going to be the exponent. And it says that our base, b, is any positive number other than 1. So again, like I said, it could be a fraction or it could be a regular integer. And then we have a couple of examples. We could do 2 to the x power. We could do 1/2 to the x power. Those would both be examples of exponential functions, again, because their exponent is a variable. So we're going to start with example 1, and we are going to be making a table of values and graphing y equals 4 to the x power. So I'm going to start with the numbers that I typically like to start with most of the time, which are -2, -1, 0, 1, and 2. Those numbers are going to change a little bit today, and I'll explain why as we go forth. So I'm going to start off with 4 to the -2, 4 to the -1, 4 to the 0, 4 to the first power, and 4 to the second power. Now let's talk about those negative exponents. This is what we just learned in the last chapter. That doesn't mean that your answer is a negative number. That means you have to flip this. So in order to make that become a positive exponent, I'm going to turn this into 1/4 to the +2, which turns that into 1/16. Now if you wanted to use a calculator, and I'm okay if you want to, that would turn into 0.0625. All right, so 4 to the -1. Again, I'm going to flip it, turn that exponent into a +1, so I get 1/4 to the 1, which is just a fourth. Again, if you want to use a calculator, that would become 0.25. Next, we have 4 to the 0 power. Again, in the last chapter, we learned that something raised to the 0 power is going to equal a 1. Then we have 4 to the first power, which is just 4, and 4 to the second power, which is 16. So let's plot these points together. We have -2, 0.0625. That is a really tiny number, and it just means that it's not much higher than 0. It's very close to being a y value of 0. Then we have -1, 1/4, or 0.25. That's a little bit higher, but still pretty close to 0. Then we have 0, 1, and then we have 1, 4, and then lastly we have 2, 16. Let's see, 8, 9, 10, 11, 12, 13, 14, 15, 16, right there. All right, so let's talk about this, because I'm going to connect those points. Now you'll notice we're not going to get a line, so it's not linear. We're not going to get a parabola, because this is not a quadratic. So what we see happening with these points is they're very close to the y-axis. They're right above it. They're not going to touch the y-axis, but they are going to be very close to it. And that's kind of hard to draw, but you're drawing something that's close to the y-axis, and then we see it start to curve. And then it shoots up, and it goes up very quickly. Now notice I'm doing arrows both directions, because I can plug in any number for x. I can plug in negative numbers, positive numbers, 0, so there's no restrictions, which means my domain is all real numbers. Remember, domain just means are there restrictions on your values for x? And remember, I just said no. You could have negatives, positives, or even 0. Range is going to be different though, because let's look at what's going on in our graph. If you look at the graph itself, you'll see that it doesn't touch the x-axis. And you know me, I'm a stickler for you guys always labeling those axes, so let's label them, right? So everything is above the x-axis. Well, what that means is that all of those y values are positive because they're all above the x-axis. And we can see that in our table of values. We start with really small positive numbers, and then they get larger. So I'm going to say that y is greater than 0. And that's what I see in my table, but it's also what I see in my graph. And then we have a new word right here that says asymptote. It's probably a word you've never heard of before. So basically what an asymptote is an asymptote is some sort of line, horizontal or vertical, of your graph that kind of helps it know which way to go. So if you look down here at the bottom, and I'm going to use a highlighter for this, I could put this little dotted line right here on the x-axis, because over on the left side of the graph, that's what it's getting close to. It's not touching it. Remember, we saw these numbers, they were getting close to 0, but they weren't actually becoming 0, but they were getting really close to 0. So that would be my asymptote. Now remember, we've learned earlier this year and back in Algebra 1 that when you have a horizontal line, which is what we have, it's going to be y equals a number. And that particular number is 0 because it's going through 0 on the y-axis. So my asymptote there is y equals 0. All right, let's take a look at example 2. Again, we're going to make a table of values. I'm going to stick with those same numbers, and you're going to see in a few minutes where those numbers are going to change. So I'm sticking with -2, -1, 0, 1, and 2. And I'm going to do the same thing to start off with. So I'm going to have 1/4 to the -2 power, 1/4 to the -1, 1/4 to the 0 power, 1/4 to the first power, and lastly 1/4 to the second power. All right, let's talk about that -2 exponent. So remember in chapter 7 when we did the rules of exponents, I told you guys that we could make that -2 become a +2 by taking what was on the inside and turning it into the reciprocal. So again, I'm flipping that fraction, and all it's doing is changing my outside exponent to a positive. Well, 4/1 is the same thing as just a 4, and 4 to the second power is 16. We're going to do the same thing with this next one because we have a negative exponent, so I'm going to flip what's on the inside. My exponent on the outside is going to turn to a positive. 4/1 again is just a 4, and 4 to the first power is 4. Now I don't have negative exponents anymore, so I don't need to do any flipping. 1/4 to the 0, we just talked about what happens when you raise something to the 0 power. It always equals 1. 1/4 to the first power is 1/4, which is the same thing as 0.25 if you like decimals. 1/4 to the second power is 1/16. We just saw that number in the last table also. That's the same thing as 0.0625 if you like decimals as well. So let's see how our graph is going to look. Again, let's go ahead and label the x-axis and the y-axis. So I've got -2, 16, -1, 4, 0, 1, 1, 0.25, again really close to the x-axis, and then 2, 0.0625, that's even closer to the x-axis. So we kind of see the opposite of what we saw in example number 1. Remember in example number 1 it started low and then it shot up very quickly. We're going to see the opposite of this. This one is up high and it drops down low very quickly, and it curves around, and I'm not doing such a great job, but it curves around and it's going to get close to that x-axis, but it is not actually touching it. So let's talk domain and range. Did we have any restrictions on our x values? Nope, because we could plug in negative numbers, we could plug in positive numbers, we could plug in 0. So our domain is all real numbers because we could plug in anything that we wanted for x. Our range, if we look at our y values, both in our table and in our graph, we see nothing but positive y values. Everything is above the x-axis. So I'm going to say that my y values are greater than 0, which also lets me know what my asymptote is. And we just talked about asymptote. We said, what's your graph getting close to? It's going to be actually that same little dotted line that we just talked about in the last one. And that is the graph of the horizontal line y equals 0. So let's talk about a couple things that we can take away from these two graphs. Going back to example 1, notice that our base was a 4. And our graph started low and then grew very quickly. So right here it says the exponential function is a blank if the base is greater than 1. So this is like what example 1 looked like. Our base was a 4. which is greater than 1. So this is going to represent a growth function. And that's exactly what happened to our graph. It started low and then it grew very quickly. Now if we look at example 2, the opposite has happened, because instead of our graph growing, if you think about you're looking at something from left to right, as we look from left to right, our graph drops significantly. And so this is an example of a decay function. And the reason that we know that also is that its base is in between 0 and 1, because 1/4, which is the same thing as 0.25, is in between 0 and 1. So before you even graph something, you should be able to tell whether your graph is going to be growing or decaying simply by knowing what the base is. Here's one other thing I want to point out to you. Let's go back to example 1. If you'll notice back here, there's nothing behind the 4 to the x power. So it would be okay if I put a plus 0, because technically there's nothing there. Whatever is back here is always going to let you know ahead of time what your asymptote should be. So I already knew before I graphed this that my asymptote was going to be y equals 0, that all of my y values, they were going to revolve around that. Notice they started by being close to 0, and then that's when they shot up very quickly. The same thing has happened in example 2. Again, there's nothing back here, which is the same thing as me having a plus 0 written back there. So again, that value right there represents what the asymptote is going to be. So if there had been a plus 5, then my asymptote would be y equals 5. If there had been a minus 8, then my asymptote would be y equals -8. So that number in the back is going to let you know what your asymptote is going to be. All right, so let's move on to example 3. Actually, let's just move on to example 4, because I feel like we have a pretty good understanding of the easy ones like that. Let's take a look at this next one that's a little bit different. So one thing that's different is we now have something else in the exponent. It's not just an x. This actually is going to change the numbers that we're going to plug into our table of values. So let me explain that real quick. So I'm going to take this x plus 1, that's the exponent, and I'm going to set that equal to 0, and then I'm going to solve for x. And I'm going to end up with a -1. That's going to be the number I plug into the middle of my table of values. So because that was no longer just an x, but it had an x plus 1, set it equal to 0, solve for x, that's going to tell you what your middle number is going to be. Now I want some numbers that are smaller than that, so I would pick a -2 and a -3. And then I want some numbers that are bigger than that, so I'm going to pick a 0 and a 1. That's actually how we can determine the numbers that we're going to use for our table of values. All right, so now I'm just going to plug it in. So for all of these, I'm going to have 4 times 2 to the x plus 1. So for this first one, I'm plugging in a -3 plus 1. All of them are going to look pretty similar. The only thing that's changing is that value of x. Okay, so let's do some solving. Got to do the order of operations, so we want to start with our exponent. So right here with this first one, -3 plus 1 turns into a -2. So I have 4 times 2 to the -2. Remember, that doesn't mean that you're going to have a negative number. That means I need to take what's on the inside of the parentheses, which is a 2, and flip it, which turns it to a 1/2. And that changes my negative exponent into a positive exponent. It looks like I might run out of room, so I'm going to be moving on over into that y column now. Now I need to perform that exponent. So 1/2 squared is 1/4, and 4 times 1/4 is 1. Again, you guys, if you feel like you want to use a calculator, you're welcome to. I'm not going to, so for this next one, I'm going to take care of the exponent first. -2 plus 1 is -1. I don't want a negative exponent, so again, inside the parentheses, I'm going to flip it, and that's going to turn that outside exponent into a positive 1. 1/2 to the first power is 1/2. And then 4 times 1/2 is 2. All right, next one, exponents. -1 plus 1 is 0. I like this one because remember, if I raise something to the 0 power, that turns into a 1. So now I have 4 times 1, which is 4. All right, now I'm going to have 4 times 2 to the first power. 2 to the first power is 2, and 4 times 2 is 8. And lastly, 1 plus 1 is 2. So my exponent is a 2. 2 squared is 4, and 4 times 4 is 16. All right, so my table of values is looking pretty good. I'm going to go ahead and label the x-axis and the y-axis, and then I'm going to plot my points. So I have -3, 1. Then I have -2, 2. -1, 4. 0, 8. I also have 1, 16. I don't have room for that one on my graph. That's okay. Now let's talk for a minute, because remember we talked about in the last couple of examples how if there was nothing written back here, for example, this is like having a +0 again, that's going to let me know what my asymptote is going to be. I already know my asymptote is going to be y equals 0. Remember, that's going to be this horizontal line right here, going through the 0. I've already plotted my points, so now I can connect them, and I know that my graph starts close to the asymptote, and then it curves and goes up quickly. So let's talk domain. Did we have any restrictions? No, we were able to plug in anything we wanted. So hopefully what you're able to tell now after doing several examples is that your domain is going to be all real numbers because you don't have any restrictions. But let's look at our range. If you look at both your y values as well as your graph, everything happened above the asymptote. Our asymptote was at 0, so above it means a greater than sign. So we're going to have y is greater than 0. So if you can identify if your graph is occurring above or below your asymptote, then you just have to figure out if you need a greater than sign or a less than sign. All right. So let's take a look at example 5. Again, it's like we have this +0 back here. So I already know what my asymptote should be. It should be y equals 0 based on that. Now I want to figure out what numbers to plug in. So I'm going to look at that exponent. The exponent is x minus 3. So I'm going to take that x minus 3, set it equal to 0, and solve for x. And that's going to give me the middle number in my table of values. So the middle number that I'm going to use is a 3. So smaller than that would be 1 and 2, and bigger than that would be 4 and 5. And those are going to be the numbers that I'm going to use for the table of values. Now don't forget there's a negative sign out front, and that has to stay with you as you are filling out this work in the middle. So don't get rid of that. Again, you're welcome to use a calculator. I like to keep my brain sharp, so I'm going to go without here. But if you want to double check my math, you are welcome to use a calculator. All right, so let's take a look at the first one. 1 minus 3 means my exponent is going to be a -2. This is great review of Chapter 7's exponent rules. I don't want a negative exponent, so in order to make that exponent become a +2, I need to take what's on the inside of the parentheses and flip it. 1/2 just turns into 2 over 1, which is the same thing as just a 2. 2 squared is 4, and the negative out front stays, and so I end up with a -4. All right, this next one, my exponent, 2 minus 3 turns into -1. We're going to do the same thing here. I want that -1 to be a +1, so I have to take the 1/2 inside of the parentheses, turn it into the reciprocal, which is a 2. 2 to the first power is 2, and I have to keep the negative sign out front. All right, 3 minus 3 gives us an exponent of 0. 1/2 to the 0 is 1, but I have a negative out front, so I'm going to end up with a negative 1. Here we have 4 minus 3, which turns into a positive 1. 1/2 raised to the first power is 1/2, but I have a negative out front, so it's going to be a negative 1/2. And last one, 5 minus 3 is 2. 1/2 to the second power is 1/4, but I have a negative in front of it, so it's going to be a negative 1/4. Now, if you used a calculator for these last two, you would have gotten a negative 0.5, and you would have gotten a negative 0.25. So if you like decimals better, there you go. All right, we've already identified our asymptote as y equals 0, so I'm actually going to go ahead and put that on my graph so I know what my graph is going to get close to. I'm also going to go ahead and label the x-axis and the y-axis, and now I'm going to plot some points. So I have 1 comma negative 4, 2 comma, no, I did that on the wrong side. Just kidding. Try that again. 1 comma negative 4, 2 comma negative 2, 3 comma negative 1, 4 comma negative 0.5, and 5 comma negative 0.25. So this time our graph is below the x-axis. Guess what that's going to change? Well, it's not going to change the domain. Domain is still all real numbers. You have no restrictions. You can plug in anything you want, but it is going to change the range because everything is below the asymptote. So this time we're going to say y is less than 0 because everything was below, less than, smaller than that y value of 0. And again, you can see that in your table of values. If you look at all your y values, they're all negatives, so they're all below 0. All right, last one we're going to look at today. So we've got a couple things. Right away, there's already a number back here. That tells me that my asymptote is going to be y equals 8. So right away, instead of going through the 0, I can go ahead and draw my dotted horizontal line right here going through 8. All right, before I figure out numbers for my table of values, I got to take that x plus 5, and I'm going to set it equal to 0, and I'm going to solve and get negative 5, and that's going to be the middle number that I use in my table of values. So I'm going to do a negative 5 right in the middle. So smaller than that would be negative 6 and negative 7. Bigger than that would be negative 4 and negative 3. Hopefully everybody's doing okay so far. Now I'm going to be plugging this in. And real quick, I'm just going to go all the way down. 1/3. All right, so I've got a negative 7 plus 5, negative 6 plus 5, negative 5 plus 5, negative 4 plus 5, negative 3 plus 5, and then behind all of them, plus 8. Okay, so here we go. Again, you can use a calculator. I'm going to go through this kind of fast orally, so if you want to use a calculator to check behind me, feel free to do so. Negative 7 plus 5 is negative 2. I want to change that to be a positive 2, which means this 1/3 needs to change to be a 3. So 3 to the second power is 9. 9 times negative 2 is negative 18, and negative 18 plus 8 is negative 10. Again, you can plug this into a calculator and check behind me. Next one, negative 6 plus 5 is negative 1, but I don't want a negative 1 exponent, I want a positive 1, which means I'm going to flip this. So now I'm going to have 3 to the first power, which is 3. 3 times negative 2 is negative 6, and negative 6 plus 8 is 2. All right, negative 5 plus 5 is 0, so 1/3 to the 0 power is 1. 1 times negative 2 is negative 2, and negative 2 plus 8 is 6. All right, negative 4 plus 5 is 1. 1/3 to the first power is 1/3, times negative 2 is negative 2/3. I'm going to add it to 8, but I need a common denominator, so I'm going to turn 8 into 24/3, so that when I add these, I get 22/3, which is the same thing as 7 1/3, or if you're using your calculator, you're getting 7.333333333, and it's repeating. All right, last one. Negative 3 plus 5 is 2. 1/3 to the second power is 1/9. Negative 2 times a ninth is negative 2/9. I want to add it to 8, but I need a common denominator, so I'm going to turn 8 into 72/9. Negative 2/9 plus 72/9 is 70/9, which would turn into, wrong number, 7 7/9. And your calculator would probably give you 7.777777777. Yeah, that would be it. Okay, so let's graph. We have negative 7, comma, negative 10. So we're starting from way down here. Then we have negative 6, comma, 2. So it's going up pretty quickly. Then we have negative 5, comma, 6. Then we have negative 4, comma, 7 1/3. And then we have negative 3, comma, 7 7/9. Notice, look at those numbers. What are they getting close to? Well, they're getting closer to that 8. Makes sense, because that's what our asymptote is. So it's curving, and it's going to get close to that, but not touch it. Domain is still all real numbers. Range, everything is below the asymptote, but this time the asymptote is not at 0, it's at 8. So we're going to say y is less than 8, which you can see that in your table of values. You can also see that in the graph. All right, so I believe your homework is a worksheet. Y'all work on that. Send me pictures when you're done, and tomorrow we will work on part 2. And this week is a short week because Friday is Good Friday. So I plan on us having a quiz on Thursday, and then you guys having a great spring break with no math homework. So I'll see y'all in tomorrow's video.